All right, just a quick note about the heating curve that was made. Usually on a sample of a pure substance, you're going to have one flat line when you bring it to the boiling point. However, as you can see from the video, we brought the mixture of ethanol and water to the boiling point. And what happened was, you can see like over here, from about 0 to 750 seconds here, especially to the 500 second mark, up to about 70, 75 degrees, it was pretty linear. So the energy being added to the mixture was being used to speed up the particles. Then after that point, it started curving off and then leveled off at around 85 degrees or so. And so when it leveled off, there was something happening. That energy was being pumped up, not to speed up the particles, but now is being used to increase the phase energy or increase the spacing of the particles, because the ethanol was boiling away. And the reason I know it's not the ethanol and the water is because, look at this, flat line, and then once we get to about 1500 seconds, right at that, we start increasing. That energy is no longer flat like it was. There's a noticeable increase in the slope here, which means that energy is now being used to speed up the particles. Well, what particles would be left after I flatlined? The only particles that would be left would be water. And so therefore, this is the boiling of the ethanol. Then I increase it, and then I boil my water. So whenever I have a mixture, they're not going to have a combined boiling point or melting point. What's going to happen is they're going to have their individual boiling points. Water has its boiling point, ethanol has its boiling point. And that makes sense because in several different ways, we use distillation as a means of separating two liquids that have different boiling points, and we'll talk more about that later.